As we have already seen, there are many different exciting applications that are being enabled by the big data era. As part of my core research here at the San Diego Supercomputer Center, I work on building methodologies and tools to make big data useful to dynamic, data-driven scientific applications. My colleagues and I work on many grand challenge data science applications in all areas of science and engineering, including genomics, geoinformatics, metro science, energy management, biomedicine, and personalized health. What is common to all these applications is their unique way of bringing together new modes of data and computing research. Let me tell you the one I'm passionate about, wildfire analytics, which breaks up into two components, prediction and response. Why is this so important? On May 2014, in San Diego County, where the instructors of this specialization live and work, there were 14 fires burning, as many as 9 at one time, which burned a total of 26,000 acres, 11,000 hectares, an area just less than the size of the city of San Francisco. 6 people were injured and 1 person died. And these wildfires resulted in a total cost of over $60 million in damage and firefighting. These wildfires can become so severe that we actually call them firestorms. Although we cannot control such firestorms, something we can do is to get ahead of them by predicting their behavior. This is why disaster management of ongoing wildfires relies heavily on understanding their direction and rate of spread. As these fires are a part of our lives, we wanted to see if we can use big data to monitor, predict, and manage a firestorm. Why can big data help? As we will see in this video, indeed, wildfire prevention and response can benefit from many streams in our data torrent. Some streams are generated by people through devices they carry. A lot come from sensors and satellites, things that measure environmental factors. And some come from organizational data, including area maps, weather service updates, and fuel content databases, which archive how much vegetation and other types of fuel are in the way of a potential fire. What makes this a big data problem? Because novel approaches and responses can be taken if we can integrate these many diverse data streams. Many such data sources have already existed for quite some time. But what is lacking in disaster management today is a dynamic system integration of real-time sensor networks, satellite imagery, near real-time data management tools, wildfire simulation tools, connectivity to emergency command centers. And all these before, during, and after a firestorm. As you will see, the integration of diverse streams in novel ways is really what's driving our ability to see new things and develop predictive analytics which may help improve our world. What are these diverse sources? One of the most important data sources is sensor data streaming in from weather stations and satellites. Such sensed data include temperature, humidity, air pressure. We can also include image data streaming from mountaintop cameras and satellites in this category. Another important data source comes from institutions such as the San Diego Supercomputer Center, which generate data related to wildfire modeling. These include past and current fire perimeter maps put together by the authorities and field maps that tell us about the vegetation and other types of fuel in a fire's path. These types of data sources are often static or updated at a slow rate, but they provide valuable data that is well curated and verified. A huge part of data on fires is actually generated by the public on social media sites such as Twitter, which support photo sharing resources. These are the hardest data sources to streamline during an existing fire, but they can be very valuable once integrated with other data sources. Imagine synthesizing all the pictures on Twitter about an ongoing fire, or checking the public sentiment around the boundaries of a fire. Once you have access to such information at your fingertips, there are many things you can do with such data. You can simply monitor it, or maybe you can visualize it. But it's not until you bring all these different types of data sources together and integrate them with real-time analysis and predictive modeling that you can really make contributions in predicting and responding to wildfire emergencies. So now, I would like you to take a moment and imagine how big data might help with firefighting in the future. All these streams of data will come together in 3D displays that can show all the related information along with weather and fire predictions, just like the way tornadoes are managed today.